Now that looks better. Does it? Yes, it does. Okay. So to get started, this guy here has a name. There's a few words. Do anyone know? Yeah. Yeah. Power. And in physics we can call it order. Yeah. And what else? There's other words for it. You can also call it an index. That's another word for it. And anyone know any more words for it? No. No? No? In Arabic it's os. Yeah. Though we don't use that here because that's Arabic, not English. But any more English words? No? Okay. Another one you can call it is superscript. Yeah.
Whoa.
Yeah. And yeah, they're the main ones. Yeah.
Which word do they always use?
The exam.
Power.
No, I would say this would be 50-50 between these two. And this is for the IFY and high school level. It's not really used.
What about other?
Oh, that's for physics. Yeah. Okay. Vocabulary. Right. So the name of the lesson is Rules of Indices. Indices being the plural of index.
Yeah.
Okay. Can I scroll down? We'll have a look at the rules. Yeah. Now, I know you know these rules already, but we'll do little proofs as well of them. So the first rule, rule 1, I know you definitely know this one. X power n times x power m equals...
N plus N.
Yeah. And the proof is super easy. It's hardly a proof. Xn times xm equals x times x dot 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 dot. Like so. And then xm is x times x dot 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 dot. Like so. And how many x's are here in the first group? There's n of them. And how many are here? M of them. So then the total would be n plus m, which you can also write as x power n plus m. So it's hardly a proof. It's nearly more of a, from the definition of what it means to have an index. But I would like you to write it down all the same. So this is rule 1. Yeah? Did you write this down? Did you?
Yeah. Yes.
Yeah, she wrote it down.
Did she?
Yeah.
Okay. I guess I can trust you. Right, can we do rule 2 now?
Yeah.
So you can probably guess what the second rule I'll do is if this was the first rule. So what do you think the second rule will be? Yeah. Rule 2 is xn over xm equals xn minus m. And I think you can see where the proof would be. Xn over xm equals x on the top and x's on the bottom. Now, how many on the top do you have? N. And how many on the bottom do you have? M. But what happens here is they can cancel. So you're left with n minus m, the difference, which is equal to xn minus m. are you writing these down? Really?
Because when you write, I write.
Okay. Okay. Now, can we do rule 3 now?
Yeah.
Yep. So, for me, what I'll do as rule 3 is this one: x, n, m, like this, a double power. Okay. And does anyone know what this is?
And multiply them.
Like this, isn't it?
Yeah.
And the proof, let's have a look. X, n, m. That's equal to x n times x n times x n, etc. x n. And how many of these are there? M of them. But according to rule 1, this is equal to xn plus n dot 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 till the end. But how many of these are there? There's m here. So what's the quick way to add n to itself m times? You multiply by m. Yeah. That's rule 3. Oh, are you sick, Ming?
No.
No. Okay. More rules, yeah. Yeah. Okay. Continue? Yeah? Okay. Rule 4 is x power, yeah? Yeah, that one. Do you know what it is? Yeah. So 1 over n, this is equal to nth root of x. And the proof, so the best way to prove this is just you say they're equal, and then you put power n on both sides. Now this here has to equal x, because if you have the nth root of x power n, then it has to be giving you x back. Okay. This one here I can use rule 3, isn't it? And this will be x 1 over n times n. But that just cancels down to make x power 1, which is obviously x, because it's just x by itself, you know? So this proof is quite short as well. That's rule 4. Yes?
Yeah.
Okay. Can I scroll down?
Yeah.
Yeah. Now the last one here, not so much a rule, but just some basic kind of values or properties, if you, or you can call it a rule if you like. So the first one says x power 1, I think this is obvious, but just to make it clear, that's equal to x. Okay. X power 0 though, that's equal to 1. And this is only true if x is not 0. 0 power n, what does this equal? 0.
Huh?
Yeah.
Oh.
And then the last one, 0 power 0 equals
One.
y. There, thank you. undefined. And the reason it's undefined is because it's not clear which two rules here would be suitable for this. According to this, we should think it's 1. But according to this, we should think it's 0.
My calculator says 1.
No. It says math error.
Are you using Casio or Sharp?
I don't think that matters.
No, it's not error.
Yeah. Go on, check it out. 0 power 0. Go on.
It's not error. You
Yeah.
just made everybody check.
Yeah. Yeah.
But like, so is it just for 0?
What do you mean? 0 power 0.
Yeah.
Mhm.
0 is like 2 power 0s.
Oh yeah, 2 power 0 is fine. 2 power 0 is 1.
So 0 power 2.
And 0 power 2 is 0.
But how do you explain it?
It's because it's not clear which of the two rules should apply here. For example, somebody could say, well, it should equal 1 because it's a power 0. But likewise, or alternatively rather, somebody could say, well, it should equal 0 because 0 to any power is 0. So there's no way to resolve which of the two it is.
Well, you
One.
can't like, use the 2 and like, use the average.
0 power 0 equals 0.5.
Yes.
Yeah, you may be the
Interesting.
the trickiest
Hi.
master.
Yeah, interesting.
Damn
That's
it.
that's wrong. I'm not even sure how to explain why it's wrong, but it is.
If I get PhD in math, I'm going to make that.
Do. And if you do get a PhD in maths, please mention me in the special thank you section at the start. Yeah, okay.
When I
Right.
publish my book,
Yeah, do, please, yeah.
the IFC.
Yeah, special thanks to the following. Yeah. Okay, so undefined is the value here for 0 power 0. Yeah, why the proof for x power 0 equals 1 actually is not as difficult as you think. X power 0 is equal to x power 1 minus 1. True? Because that's the same, isn't it? But if I use rule number 2, then this is equal to x1 over x1, which is equal to x over x, which is equal to 1.
Hi, Mas.
Yeah? Yeah. And also, Marwan, the reason for 0 power n is because it's equal to 0 times 0 times 0, which is obviously 0 here.
Mathematicians will calculate for 0.
Okay. Continue?
Yeah.
Yeah. Let's have a look at some examples now. Can I scroll down? Yes? Okay. So, first example, we'll keep it not too difficult. We'll say x squared x cubed over x5. No, x15. Yeah, okay. So on the top, what do I get?
S5.
5. And on the bottom? x15. And this will be equal to x power
Minus
10. Which you will just leave like that. Okay, write that down. It's the first example. Come on now. Did you write this
So
down?
isn't there a rule for this too?
Say again?
There's also a rule for that too, isn't there?
Yeah, I mean, you can think of it as a rule. But you're right. If you want, you can think of the rule x minus n is 1 over xn.
Yeah.
This is a little bit like, it's kind of like rule 2 though for me.
which is most simple.
Yeah. In the exam, often they would want you to leave the answer like this, and the reason for that is because they're testing the rules. So they don't really care that you change this into x power 1 over x power 10. Because they're testing that you know this rule and that you know this rule.
But you won't get penalized for it.
No, I don't think you would, unless the question said not to do it, you know? Alright, are we okay with that? Yeah, we'll do another example? Okay, so I'll scroll down. I'll give you one to try actually. Let's see. I want you to simplify this one here. X squared cubed over x squared. See what you get for this. Should only take you a second or two. Got it? Yep. What is it? No. X power 2. X power 6 over x power 4 gives us x power 2. Yeah? Yeah. X power 2. You know? Like the number of oxygen atoms in the room. Yeah, okay. Right. Okay. Now, next example. Let's give you something a little bit harder now.
Okay.
So, we'll say 2, 4, 3 square root 9 over 27 fourth root 81. See if you can calculate this for me. No calculator. No calculator.
Is this is a
Fourth root.
fourth root?
Yeah. Yeah. Now, I think what makes this easier to do is you realize all these numbers are trees. So this one, 243, I think that's 3 power 5?
Yeah.
243 is 3 power 5?
Yes.
Yeah.
And obviously 9 is 3 squared, right? And square root makes it power a half. And 27 is 3 cubed. And this is power 1 over 4. And 81 is 3 power 4. So what's really nice here is when these multiply, what happens? Yeah, they cancel, don't they? So you're left with 3 over 3. What happens there? Cancel. And then here what happens? The powers? Yeah. Right. Right, let me give you another one now. Can I scroll down? Yeah. Now, I'll give you one more and then I have to show you something else in a second. So, let's see, can you simplify for me? B power minus 3 times square root b power 5 over b cubed square root b. Try this one for me. You got an answer? So you can change this into b minus 3, b power 5 over 2, b cubed, and b power 1 over 2. Yeah. Now on the top, the powers add. So that's minus 3, so that's minus a half, I think. No, it's this, isn't it?
Yeah, yeah.
And then on the bottom, it's 7 over 2. Then the powers minus again.
Yeah.
That's b minus 8 over 2, which is equal to b power minus 4. Did you get that? No? Do you know where you went wrong? I'll write this down.
Why can't you say?
Sorry.
Oh yeah, no, there's more than one way of doing it though.
Oh, but you won't get b minus 1 then.
No, then, yeah.
So like b, sorry, square root b, so root b raised to the power 5
Yeah.
is root b raised to the power 5 times
To the power.
yeah, to the power of like b5 then drop it.
A half, yeah.
Yeah, then there's also half at the bottom, so
Yeah.
make the two halves
Sorry,
cancel.
No, they don't cancel.
I've still I
Okay.
use 1 over 5, no 1 over 2.
Okay, okay. Can I scroll down? Can I scroll down?
Yeah. Keep going.
Yeah? Yeah? Okay. So the next thing I have to show you is this constant. So you know there's constants in maths which are quite important, like square root 2 is an important constant, and pi is an important constant. And this one here is a new constant that we haven't talked about called e. And just like pi and root 2, it has an infinite, its value is irrational, it continues infinitely. So for the first few values, 2.718281828459045, etc. Well, of course.
Hey!
This, before they give you your degree in Trinity, the day before they ask you for this, and if you don't get it, you don't get your degree. Yeah.
Sorry, how many numbers does it consist of? Does it
Infinite.
Goes on and on and on.
So where do you stop?
Yeah, well the calculator I think stops, where does the calculator stop actually?
But is
Four.
it on the
It stops where you
Yeah.
stopped. For
Here?
It stops that.
In
After the 8,
Yeah.
like here. So that's the value you use, because that's the one on the calculator. Yeah? So, what we want to have a look at is graphs of this function. Rather, I mean graphs of the form a constant, the constant e, constant, and x here. Depending on the value of a and b gives us different shapes. Okay. Can I zoom out a bit here, and I'll show you what I mean. So, I'm actually going to break the screen up into 4 screens here, because there's 4 situations I want. Actually, do you know what? Y equals A, E, B, X. Right. I'm going to give you 4 graphs. So, X, Y, X, Y, X, Y, X, Y. And the shape you get depends on the A and the B. So I'm going to look at first if the A is a positive and the B is also positive, then I'll do A is negative and B is still positive. Then I'll do A is positive but B is negative, and lastly A is negative and B is negative. So the first situation is the most common. A and B are both constants, are both positive constants, and the graph you get will look like this. It will exponentially increase. Does it touch the x-axis? No, it doesn't actually touch the x-axis, and is never negative, and it always increases. Okay, and I wonder if anyone could figure out what this point here is.
One. Oh, no.
So 2.1. 3.1.
Half.
A.
Wait.
Because if x is 0, what's b times 0? And e power 0, 1, and 1 times a? A. So this point here is a. Always. Okay. If the a is negative, but the b is positive, then what has happened is the graph flips upside down. So it's in the negative now. But it never touched the x-axis still. If the a is positive, but the b is negative, then it decreases to the x-axis. Like this. Okay. And if the a is negative and the b is negative, it's upside down, decreasing to the x-axis. Or rather, convergent to the x-axis. These are the 4 possibilities here. I think you should copy them, please. Oh, Ming, you couldn't have copied them already, have you?
No, I don't.
Okay, you're going to copy them now, yeah? Yeah, okay.
It's right.
Great. You've seen this graph recently. Where have you seen it? No? No? Where have you seen this graph recently?
No, in the first step class.
Recently. Where? This is the graph for coronavirus outbreak, isn't it?
Oh,
The number of cases. Yeah, you saw that video. Yeah. The number of cases. It starts off flat and then it turns upwards like this. Yeah. Yeah. Most diseases follow this shape. Although what's different is this graph continues upwards forever, whereas for diseases it levels off and then comes back down. Yeah. Good question. Okay. Do you have this? Yes? Got it? Yeah. Now, let's have a look at what ones you can do now, and then we'll have for practice of these for a little bit, and then we'll have a look at a tutorial. Now, I kind of feel like I'm a little bit behind, like a couple of classes in maths, like 2 or 3 classes. I know we missed one class of maths this week because it turned into physics.
Yeah.
But
Meant to be double.
did something else happen this semester that made us miss a maths class or two? Did we miss maths classes because of the university?
No, the week we were trying to catch up on physics, I think we missed a class or not.
Ah, that explains it. Okay. No, I could kind of tell I'm like 2 classes or so behind a little bit. But that's okay. I can make that up for the maths, no problem. I remember that now, yes. Okay, do you have that copy down? So, what I want you to try now, and you can finish it at home. 1A to H. No, actually, now to prevent any confusion, A to H. 2A to H.
Physics.
5A and B. 6A B C A to D. I don't need you. Okay, so you have a choice here a little bit. If you use your calculator to do question number 2, then you must also do question number 3. But if you don't use your calculator to do question number 2, then you don't have to do number 3. So you only do 3A to H if used calculator in question 2. So I recommend you don't use a calculator in question 2. Otherwise, you must do question 3. So it's your choice. You can either use the calculator in 2 and do 3, or just not use the calculator in 2. No, not even the check. No calculator in 2. Alright, try these for a few minutes and then we'll have a tutorial.
Is there anything like root 1?
Say again?
Is there anything like root 1?
What one? What do you mean?
Root 1.
Root 1 is just 1. Come on, guys, work.
There's D and Dutch same.
Exactly the same?
Yeah.
Okay. We'll just do one of them then.